For this next example, I'm going to show you how to eliminate parameters. With this first equation, we are going to use a trig identity to help us eliminate the parameters. So let's take a look at this example. In this example, we have x equals r cosine t. We have y equals r sine t. And the restriction we're given here is that r is greater than 0 because we're going to find that this ends up representing the radius through this process. So if I'm trying to relate cosine and sine by using trig identities, I think of the Pythagorean identity, which is sine squared plus cosine squared equals 1. Now notice in this form, right now I need to go ahead and move the r to the other side. So what I'm going to do here is let's divide by r on both sides. And then also I'm going to divide my y equation by r as well. That way I can substitute in y over r for sine t, and I can substitute in x over r for cosine t. So whenever I do that, I end up with y over r quantity squared plus x over r quantity squared equals 1. Then I'm going to distribute that squared to both of those pieces, and I get y squared over r squared plus x squared over r squared equals 1. Since both of these share a denominator here, I'm going to eliminate that by multiplying by r squared on both sides. And what we end up with is the standard equation of a circle. So in this situation, what we have here, x squared plus y squared is r squared, is a circle that is centered about the origin with a radius of r.